chapter 2. Okay, big difference. Functions that involve a radical with a variable in the radicand. What's the radicand? New book, right? It's purple, it's down the bottom.
The radicand is like the thingy.
The thingy, okay, let's get more specific about the thingy.
It looks like the hat.
Oh, that's the index.
The radicand's like the thing on your side, right?
Right, so this is the radicand.
Close enough.
Close enough. This guy here, the type of root it is the index. And the whole thing is called a radical. So if you have a radical with a variable in the radicand, such as these two, those are what we call radical functions. This guy, not a radical function. Anybody know why? What's the difference between this one and this one?
There's stuff outside.
There's stuff outside. There's stuff added to it, stuff like that. That has a variable. That's the thing. You can add a number to it, easy peasy. Like that's, like I could add, and that's still a radical, but because this one has a variable in it, it's a no-go. Okay, here we go. Let's graph your very first basic radical function, everybody. I want you guys to be purposeful when picking your table of values. We're square rooting the x's. Do I want to take the square root of 2?
No.
I hope not, because we're not going to have a calculator.
We know what the square root of 2 is, though. It's like 1.41.
Oh yeah, we did a lot of that, eh? But wasn't that divided by 2?
What? No,
Root 2 divided by 2?
No, just regular root 2 is 1.41, so.
Is it?
It is.
Are you sure?
Yep. That sounds familiar.
Oh yeah, it is. Thomas, you're so brilliant. But maybe, for the rest of us mere mortals who don't remember it, can x be negative, I guess is a better question. Can I square root a negative number? No. So can my x's be negative? No. Okay, and then we said x's are being square rooted, so we want to be purposeful. What's the smallest number that's not negative that we can square root?
1.
Go lower. Mm-hmm.
Wait, 0?
0. What's the square root of 0? It is also 0. Okay, what is the next number that's easily square rooted?
1.
1.
Yeah, 1. So it's
What's the square root of 1?
1.
1. All right, what's the next number that's easily square rooted, not 2? 4. Next one? 9, 3, 16, 4, 25, 5, 36, 6. So we're just going to be super purposeful with this. What do we know about the domain of this function? You guys already told me about it. Can x's be negative?
No.
No.
So where does my domain have to start?
0.
0. All right. Can my y's be negative?
Yes.
Yeah. They can. In this case or not, but. Okay, so let's graph this one. I gotta do some increments. Let me grab a different color.
So do we have to graph a positive and negative square root for each of these?
No, we're gonna go with the positive principal root.
Okay.
Okay? Okay. How far do I want to graph? 2, 4, 6, 8, 10, 14. We'll go to there. And then my y's are nice and easy. Okay. I got my increments on there. Life is good. And can you guys graph that table of values? I did marker quizzes yesterday. They are online. If we want to see them after the lesson, we can do that too. I have feelings, but I will reserve those feelings for another day. All right. 0, 0. And then I have 1, 1. And then I have 4, 2. 9. And 3. And then I think I'm done graphing after that. Oh, I'm done plotting points after that. I think I'm done. Can somebody do me a favor in their handy dandy calculator and do the square root of 0.5 for me?
0.707.
Yep. Isn't that weird? Because usually square roots reduce the y value, right? So they're going to reduce the y value. But in this case, like 0.5 is going to be really close to 1 here. Whole numbers, it works that way. And you guys are like, why are you telling us this? So what I need you to know is that between 0 and 1, we're going to get this little bubble. It kind of bubbles up between them. Not a significant bubble, but it bubbles up between them. And then I'm going to go ahead and connect these dots. Pretty straightforward. I'm going to put an arrow on this graph because we could keep going. Our table of values kept going. But there's that bubble right there, kind of between the 0 and the 1 on the domain, because it's all decimal values. And when you root a decimal value, you get a bigger decimal. So weird. Decimals are weird. So ta-da, you've done your very first radical graph. And just like in our sine graphs, cosine graphs, tan graphs, whatever, there is a basic function. This guy's it. How do you feel about that? We're all good with that? Not really hard. It's very purposeful, the values that you're going to pick. So you're going to work smart. You'll still work hard. I'd like to tell you that you're not going to, but you will. And that's it. I'm going to flip the page. All right. Graphing radical functions using transformations. This is chapter 1 sneaking back at you. All right. So we're going to use those same things from chapter 1. A outside of the bracket results in a vertical stretch. Right? By a factor of, and it's just A. It's just A. It's straight up. It's happening on the Y's. So it's going to tell us a straight story. If it is negative, so if A is less than 0, that means we're talking about negative numbers. That just means that I'm going to see a reflection.
Please excuse the interruption. If there are any grade 9 students who need to get their picture retaken, you can head to the computer lab upstairs in room 212. Thank you.
Okay, not us. So if it's negative, you're going to have a reflection in the x-axis. B results in a horizontal stretch, but it's attached to the x's, so we're going to have that flip. We're going to have that factor flip. And what I've noticed from you guys is you're losing this. You're losing that statement. You're like horizontal stretch, 1/2. Nuh-uh, that's not the correct language. Horizontal stretch by a factor of 1/2. So we're putting all these transformations on all these other graphs, so get used to the language. I don't want to have to deduct you a 1/2 mark on your provincial exam, or you lose out on a full mark because you didn't put 3 words in there. Again, that means it's going to be a negative number and will be reflected in the y-axis. H is your horizontal shift, and we know that it does things differently. So if it's add, we move to the left. If it's subtract, we move to the right. And then the K out here is going to be your vertical shift. So all that shouldn't be too scary for you. But it's all part of it. But you've seen it before. Okay. Oh, we didn't state the domain and range for that other graph. Can we flip back and state the domain and range? I saw it, we talked about it, and then I didn't do it. So what's the domain for this guy?
0 inclusive to infinity.
Perfect. And then the range?
Same thing.
Same thing. Oh, that was a,
Did you say it could be negative?
but we're talking about this graph. We're doing the domain and range of this graph. So it could be, but in this graph it's not. So your basic graph is going to go from 0 to positive infinity. Notice that I don't have an arrow on this guy, on the starting point, because there is a starting point. So what you need to know is this, your radical graphs will have arrows on one end and not the other. Because we're going to translate this starting point to somewhere else on the graph in this next one, but it still doesn't go backwards. You know what, does that make sense to everybody? So if it doesn't have an arrow on it here, it shouldn't have an arrow on it in your new graph. Okay, so we can do a whole bunch of stuff. We can look at our original graph, and this table is really easy to do. Right? That's the original one. So what's happening here if we were to do a mapping rule? We're shifting 2 units to the right. So what am I doing to the x's? What am I doing to my x's if I'm shifting 2 units to the right? I'm adding 2. And then the y's, I've got a +1 on the outside. So I'm adding 1. So my new table of values, all my x's are going to be add 2. So 0 is going to turn into 2, 1's going to turn into 3, 4 will turn into 6, 9 will turn into 11, and 16 will turn into 18. And for my y's, I'm just adding 1. So 1, 2, 3, 4, 5. So this point translates to that one. This is my start point. And it has no arrow on it. So this guy won't have an arrow on it. We know that there was a bump between 0 and 1. We had a bump. So between these 2 points, we're also going to continue that bump. So the things that are happening on that original graph, we're just carrying them over. We're just putting them in a different space. Everybody good with that? So now we're going to graph some stuff. Two, 4, 6, 8, 10. All right, all my values are positive, so I'm not worried too much about the negative ones. Doing a full deep dive there. So I'm going to go ahead and graph these. So 2 and 1, that is my starting point, so it will have no arrow on it. And then I'm going to have 3 and 2, and then 6 and 3, and oh, I don't have an 11. So little bubble. Oh, that's too flat there. Little bubble. Okay, I'm going to try again. I hope you guys did better at connecting your dots than I did. Did you guys do better at connecting the dots? Not the best, not the worst. It's supposed to be a little bubble there, but once I erase it, especially over like a photocopied coordinate plane, it just tends to be a little bit, it doesn't want to rewrite it, which is kind of a pain in the butt. Not too terrible, eh? Not too terrible. Oh, I was supposed to do domain and range again and I missed it. Okay, what's a domain on this guy?
2 to infinity.
So inclusive of 2 to infinity. And range 1 and positive infinity. And some of you need to work a little bit harder on distinguishing between squares and rounds. Like sometimes I have a hard time seeing if this is a round or, oh, it was meant to be a square. And I was like, that looked like round to me. So do me a favor and don't make me guess. Please and thank you. Okay. This is one of the trick questions. Do you guys know what the trick is? Pardon? Nope. That's a stretch for sure, but there's a trick that is inside under the bracket or under the radical sign. No, it was on your quiz number 1 that you just did. It was in. If there's a coefficient here and there's no brackets, you have to physically factor it out. That was on your last trigonometric sinusoidal functions. Lots of people miss the trick. So unfair. So unfair. I really enjoy doing mapping rules more than words. It makes more sense to my brain. But when we're walking through this, I know that we have a vertical stretch by a factor of 3. What does that mean? I'm multiplying my y's by 3. Am I adding anything to my y's? No, because there's nothing added outside the radical sign. Anything outside the radical sign is going to affect the y. Anything under the radical sign is going to affect the x's. What does this tell me? What's happening with the graph?
Reflected in the y-axis.
Reflected in the y-axis. And then what does this tell me?
Move right by 1.
Move right by 1. Okay, so if I put that all into a mapping rule, so my x is going to be negative, and then I'm going to add 1 to it. Y's I'm going to multiply by 3. Okay, so again, if I go back to that original table, if I go back to that original table, I hear a phone ringing. It's really... And now I'm going to build my new table. So my x's are times by -1 first, and then add 1. So this one's going to be 1. This one will be 0. This will turn into -3. This will turn into -8, and this will turn into -15. How do we feel about that? Not terrible, it's transformations on radical functions. And then the y's we're just timesing by 3. Okay. So I'm going to go ahead and graph this now. I missed one. I didn't go all the way into the positives because I'm not going to spend a ton of time there. Go ahead and graph this table. So I'm at +1 and 0. So again, if this is my start point, there's no arrow on the original graph at this point. There's no arrow on the transformed point. 0 and 3. -3 and 6. And then I have -8 and +9. That's about as good as I'm going to get there. So again, little bump. And my arrow is going to continue on. I keep thinking somebody's standing in the doorway of the room, but they're not. It doesn't say to do the domain of range, but I'm on a roll, so. What's the domain of this one?
Negative infinity to 1.
And then the range?
Oh, 0
0
and
and
positive infinity.
Okay. Am I okay? Am I good to go? This one, another trick one from the transformation unit.
You just factor from C to the right side.
Bring the who? Where?
Bring the 3 to the
Right.
side.
So it's going to be y equals negative square root 2x plus 3. So again, before I even get started, I'm looking at things, anything that I have to move around before I do my mapping rule.
Reflected in the x-axis.
Reflected in the x this time. Horizontal stretch by a factor of 1/2. And then y's,
Just adding 3.
we're just adding 3. So for the y's, multiplying by 1, adding 3. Anything outside the radical has to deal with the y's. Anything under the radical, the radicand, has to deal with the x's. So x is the only thing I'm doing is timesing by 1/2. And the y's, I'm timesing by -1, and I'm adding 3 to them. I like the mapping rule because it tells me the math I have to do. I mean, the words also tell me the math, but they're words. I gotta write them down, and I don't have time for that. So again, I'm going back to that original table. So easy to flip it though. Like, I almost wrote 4 there. You can kind of see I was writing 4. Just because it kind of makes more sense in my brain, but it really would mess everything up. I use decimals, and I hope you guys are okay with that. Feel free to use fractions if you want. So this one's going to be 3. -1 plus 3 is 2. 1, 0, -1. Okay, we're gonna go ahead and graph it. And hey, you guys told me that we'd have a reflection in the y-axis here, and we did. It usually, the radical graph usually goes this way, the arrow's pointing to the right. This time the arrow's pointing to the left. In this graph, you told me there'd be a reflection in the x-axis this time, thanks. So normally we are in the positive y's, and we kind of scoop up. I guess it's not really a scoop. We kind of travel in an upward direction. This time we're going to end up scooping down. Does that make sense to everybody? Like when you think about your reflection first, I'm anticipating that I should have negative y values, right? And I do. But we moved 3 units up, but you're still going to see that scoop like it's flipped upside down. Okay, go ahead and graph. Not my best, not my worst, but. So we now see the graph before it kind of was like a lobbing a ball. Now we're kind of, we're overhand throwing, now we're underhand throwing. Domain and range on this guy. So 0 inclusive to positive infinity. Range negative infinity to positive 3 inclusive. I think as time's gone on, my infinity signs have gotten worse. Am I good to flip the page? You guys know what's going on? All right, now we're just throwing stuff around. Ooh. Okay, this is the harder stuff. Creating equations. Everybody good? You're emotionally prepared? Any shifts on this one? Okay, maybe the first thing we're going to do is we're going to graph the original function. So 0, 0, 1, 1, 4, 4, 2, and 9, and 3. Okay, I think I did way better with that radical graph. So that's y equals root x. Like, so if I was to drop that original function on there, that's what it would look like. Right away looking at that graph, what do you notice? It's kind of squished down, right? We're not as high as that original function. So I would say that we have vertically compressed the graph.
Divided by 2.
Maybe divided by 2. How did you get that?
Some of the y values are half.
Okay, some of the y values are half. All of the y values, I think, are half.
Yeah.
Okay, so that was good. Everybody good with that? How would you find it algebraically? Anybody? Okay, maybe let's start here. Any translations, like any shifts left, right, up, down? How do we know that? You're all correct. You are 100% correct. Those head nods, 100% correct. But how do we know that? Because when you have to do this on a graph that isn't this one, how do you know that? It's the starting point.
The starting point is still 0, 0.
Yeah. Because 0, 0, 0, 0 is the only numbers that if you multiply by it, it's still 0, right? So if I had a vertical stretch by a factor of 3, if I times 0 by 3, I still am at 0. So this point, if it started over here, then I know there'd be a translation. But there is no translation on this one. So I know that there's no shifts. Yay us. Okay, so you guys are talking about a vertical compression. We're getting squishier. So we know that we want one with a vertical stretch. What letter is associated with a vertical stretch? A. Okay. So determine two forms of the equation. So we're going to do one with a vertical stretch. Just a vertical stretch. So we're going to have y equals a bracket x minus h and then plus the k outside. So what do we know about the shifts? What do we know about the h and k? There's nothing. There's zeros. So we have, this is redundant. You don't need to write that if it doesn't make any sense to you, but those are our shifts. It has to do with this. Okay, let's do some math. Pick a point for me, ladies and gentlemen, on the new graph. Pardon? 1, 1 is not a point on the new graph. The new graph is this guy.
0.5 and 1.
Okay, so y is 0.5 and x is 1. What's the square root of 1?
1.
Brilliant. And Prince, what did you say you thought the vertical stretch was? You told me what it was? A half. That's a half. So the new equation, I guess the equation would be y equals, and we said a is 0.5, so 1/2 root x. We're taking that original graph and we're vertically stretching it by 1/2. Does that make sense to everybody? We're good with that? All we did was some math. All right, now we're going to do a horizontal one. And you're like, but I don't see the horizontal. And that's okay. So that one was the obvious one. Like, that's the one that we saw makes sense. The y values aren't as high, so we must have done a compression there. So now, what letter associates with a horizontal stretch? B. So notice I left off the B in this one, and I'm leaving off the A in this one, because I just want it to be a horizontal stretch. So I'm saying, hey, there's no combo stretches here, one or the other. So y equals, are you guys okay if I just jump to that? Because we know these are 0 and 0. Is that okay with everybody? All right, so we're going to use a point. So we're going to have 0.5, B, and x was 1. Okay, so this one's a little more difficult.
Is this root b equals 0.5, and then we have to square root b.
Square both sides.
Please excuse the interruption. All grade 10, please get the retakes done to attend the computer lab in room 212. Thank you.
Okay, so please note what we found was the value of b. Okay, it wasn't, so if b is 0.25, is b of 0.25, what is it being multiplied by? By a factor of? By 4. We're doing the reciprocal of it, right? So when we go to do the equation, because at 4, we're now at 1. So the equation would be because if we took that table of values and we multiplied all the x values by 4, 0, 0 would stay the same, 1 would be stretched to 4, the y value would still be 1. And that is a point on this graph. So 4, 1 is a point on this graph. Does that make sense to everybody? Sort of, kind of? We'll do our best. Okay, what would be the next one? So 4 would translate to 16. Everybody agree with me there? 4 would translate to 16. That value would have been 2. And if we look at this doesn't go to 16, but 9 is only at 1.5, right? So if we extended that, 16 would be at 2. So you could achieve this 2 different ways. You could achieve this graph 2 different ways. You could have done a vertical stretch by a factor of 1/2, or you could have done a horizontal stretch by a factor of 4. And it would have resulted in that same graph. So yeah, fun times. Just so you know how to tackle that. Let's talk about this guy. Determine the equation of the function and the equation of its reflection in each quadrant. First of all, let's figure out its equation. What do you guys see there? The original one would be 1, 1, 4, 2.
It's double.
What's doubled? The height or the width?
the height.
The height. So what are we timesing the y values by? 2. Any translation, any shifts there?
No.
Nope, because we started 0, 0. So what's the equation of this graph?
Y equals to 2 and then root x.
Brilliant. So you just found the answer for quadrant 1. All right. What would be the equation in quadrant 2? So now our graph would go here, it would go like that. What's that equation? Where have you reflected in? Let me get rid of this guy. The y-axis. So what am I multiplying by -1? The x. So we would have y equals 2 negative x. Let's look at quad 4 next, just because it makes my brain a little happier. So now this way, guy's going like that. So we're looking at from this to this guy.
Reflection in the x, so negative 2 root x.
Yep. Okay, and let's do quadrant 3. All right, so let's talk about this. Quadrant 3, I'm gonna have to flip into quadrant 2, and then I'm gonna have to flip into quadrant 3. So this one is going,
Both of them are negative.
so both things are negative in this one in order to make it happen. So y equals -2 root negative x. So again, nothing new here. There's nothing new for the reflections and the transformations. It's all the same stuff from chapter 1. So you're getting really good at chapter 1. But now we're applying it to a really, really specific function, which is radicals. Okay, no one cried yet. This is good. Are we almost done this lesson?
Nope.
Yeah, one example left and it's silly. All right.
63 degrees is the coldest temperature in Canada.
Maybe at some point. I feel like we've been colder than that, but I don't know that.
It doesn't say negative.
It should. I feel like maybe that's not a true statement then. I lost a negative. All right. We are. Oh. Okay, Justin's physics textbook states the speed in meters per second of sound in dry air is related to the temperature in degrees Celsius by the equation given here. Determine the domain and range in this context. I want to say I've seen this on a provincial exam, and I think I gave it to you on a test or a quiz. Okay, first of all, let's talk about what's on the domain and what's on the range. What's on the domain? What's on the x-axis? Think about what's under the radical in your basic equation. What's under the radical sign in your basic equation?
T over 273.15.
Okay, so what is my x-axis? This is temperature, right? Can I have positive and negative temperatures?
Yes.
Yes. All right. What's on my y then? What does S represent? Speed. Thanks. All right. So the reason why I asked that question is it might help us better. Can speed be negative? No. No. Velocity can. But we're talking speed in meters per second. So we're going to assume that speed is positive only. So can we do our range right away?
Yeah.
Okay, so what's our range? Okay, no. Yes, for speed, yep.
And then negative infinity and positive infinity for temperature.
Because what do we know can't be under the radical sign? Negatives. So this thing can't be, oops, a negative. So you guys are just going to do a restriction. So if you were to say 1 plus t over 273.15 has to be greater than 0. Can you guys solve for t in that situation? Yeah?
Negative 273.15.
Negative 273.15.
That would just be 0 Kelvin, which is no heat.
What?
Wouldn't that be all? Yeah.
Say what? What are you guys talking about?
Negative 273.15 degrees Celsius would be 0 Kelvin, which would
Oh, okay.
be no heat at all.
Okay, sorry, you guys are talking physics. I thought we were talking numbers here for a second. You guys are off in a physics world, which I love, but what is that? So I'm just trying to finish the restriction, right? So from this tells us our domain. T must be greater than, ooh, you know what? It could also equal, because we can take the square root of 0, right? So T has to be greater than or equal to negative 273.15. So say that to me in a domain statement. What's my lowest value?
Negative 273.15.
Okay, brilliant. 273.15. What's my biggest value?
Infinity.
Infinity. I mean, I think there should be some restrictions on this, but we're not physicists. Because our temperature shouldn't go up to infinity. But we're pure mathematicians here, so we're not going to worry too much about it. Obviously, a round bracket around that. What about this guy?
Square bracket.
Square bracket, because if I substitute that into here, I'll get 0 under the root sign, and that's okay. So there's my domain. So that's how I'm going to tackle that one. This is a question on your test. Hint, hint, nudge, nudge. So just make sure you know how to do a restriction of a radical. Okay, guys, this is just some plug and chug stuff. Determine the speed of sound to the nearest meter per second. So where is that 20 degrees going into? T. And what did we say negative 273.15 was? 0 kelvins?
Yeah.
And there's no heat at that point?
Yeah.
So it makes sense. So what's the speed of sound here? Anybody feel like jumping out their calculator, or do you want me? I have it in my notes. Okay. 3.
3.2146.
Okay, so the question said to the nearest meter per second, so we're not dealing with decimals. So 343 meters per second. Do we need to do all of these? What do you guys anticipate as the temperature gets colder? What's going to happen to the speed?
It's gonna get slower.
It's going to get slower. Do we need to do all of these? This should be a negative. Do you want me to tell you what they are? Do you care? Just tell me. Okay, fair. We'll fill it out just so our notes are complete, but what I'm hearing is nobody's really concerned about this. I guess maybe what I'd like you guys to do is do 1 in your calculator, just so you feel confident. You feel confident that you could solve it. I don't know what's going on with your calculator. Don't forget to throw that negative sign in there. I would either put brackets around this or change that to a subtract sign. I wouldn't just leave that willy-nilly like that. So just pick one, and I want you just to double check that you're confident that you can use your calculator to solve for it. And I will just keep going with filling this in. So 2. Did you get 343? Yay, calculator! Was not working yesterday. I always do that in my calculator. It just makes my brain feel better.